India has landed on the moon. Scientists rejoice as Chandrayaan-3 lands. The craft completed a technically difficult drop to the lunar South Pole. An Indian spacecraft has become the first to land near the moon's rock and crater-strewn South Pole, making India the world's fourth country to successfully settle on the body. The spacecraft's landing, dubbed Chandrayaan-3, is a huge accomplishment for India's Indian Space Research Organisation, which attempted but failed to land on the moon in 2019 with precursor missions Chandrayaan-2. ISRO stated that it has established a communication link with its lander and broadcast images of the module's rover rolling onto the lunar surface. According to cosmologist Tarun Sauradeep, who runs the Raman Research Institute in Bengaluru, India, the achievement represents a powerful, emphatic restatement of India's growing global stature and capability in science and technology. It will motivate Indian scientists to take the lead in the emerging and unavoidable global quest for moon-based scientific and technological enterprise. The icy attraction. On July 14, India's third lunar mission, Chandrayaan-3, took launch. The launch launched a 3.9-ton spacecraft into orbit, carrying a 1.75-ton landing module called Vikram, which carried a 6-wheeled robotic rover called Pragyan. Pragyan will circle the landing site for 1 lunar day, or 14 Earth days, once deployed. The moon's south pole, a difficult place to land in, has piqued the curiosity of many nations due to the likelihood of water ice there, and massive craters nearby could provide information about the composition of the early solar system. Several missions are planned for the next years, and on August 19, a Russian craft dubbed Luna 25 crashed into the moon just days before attempting a landing at the moon's south pole. The recent crash of Russia's Luna 25 spacecraft is a stark reminder of how difficult it is to successfully land on the moon, says Mark Norman, a planetary geochemist at Australia's National University in Canberra. Landers from Israel and Japan have also crashed while attempting to land on the moon. Only China's Chang'e missions have successfully landed on the moon and conducted surface activities in recent years. Only the United States and the Soviet Union have successfully landed a craft on the moon's surface. According to Kavya Karampuri, a mission systems engineer at Bengaluru-based business Collide.io, which specializes in Earth observation-based space data analytics, India's accomplishment instills confidence in the technological ability of India's space sector. According to Karampuri, it might attract worldwide investments in the Indian private space sector, as well as stimulate international collaboration and innovation across universities, labs, startups, and research communities in India. Chandrayaan-3 is the successor mission of India's partially successful 2019 mission, which launched an orbiter with 8 operational instruments. However, in the closing moments of landing, the lander carrying the moon rover smashed into the lunar surface. ISRO learned from that setback and made many design improvements to the mission's lander-rover section. These include a new laser sensor to measure the spacecraft's real-time velocity relative to the moon, algorithms to handle unexpected deviations in propulsion or trajectory and better judge the landing terrain, larger and more solar panels, more fuel, and a heavier lander with 4 sturdier legs to handle a faster landing velocity. The craft also targeted a bigger landing area of 4 km by 2.4 km, as opposed to a 0.5 km by 0.5 km location for the previous mission. Rocky terrain. Landing at the moon's south pole is difficult since the spacecraft must be positioned at a different angle than previous landings, and the terrain is harsh. According to Norman, this entails placing the spacecraft in a polar orbit that is perpendicular to the moon's orbit. This requires additional energy to move the spacecraft into an unnatural orbit, which introduces uncertainties on critical aspects such as velocity and location of the spacecraft. According to Norman, the problem is exacerbated by a lack of accurate data on the gravity and surface properties of the location. For example, if the spacecraft lands in a crater, on a slope, or the lander's leg becomes entangled in a boulder, the mission could be jeopardized. Moonquakes near the area complicate matters. According to geologist Soumitra Mukherjee of New Delhi's Jawaharlal Nehru University, whose team analyzed images sent by India's first lunar mission, Chandrayaan-1, which launched in 2008 and detected cliffs and signs of displaced underground rocks in 2 craters near the lunar south pole. Another issue is the sun's poor lighting. Some areas are completely dark, Others are in the light, but with extreme sun angles, essentially blocking out any terrain features, says Torrin Clark, an aerospace engineer at the University of Colorado Boulder. This contrasts with the Apollo landings, where the landing sites and timing were specifically chosen to ensure quality lighting of the lunar terrain, such as rocks and craters. The success of Chandrayaan-3 comes just a week before ISRO's next major mission, its first to study the Sun, which is set to launch in the first week of September. So, there you have it. Let me know what you think in the comment section. Thank you for watching. See you in the next one.